Let's look at this question. If YB is 1.5 feet, this is YB. This is from here to here, from point A, the vertical, to point B. And look at this question. Determine the largest weight of the crate and its placement X. So he wants to know the crate. Look at this crate and the distance X. So he wants to know the weight of this, and the distance X. So determine the largest weight of the crate and its placement X so that neither cable segment AB, look at AB, BC, or CD is subjected to the tension that exceeds 200 pounds. So it should not be subjecting a tension of more than 200 pounds to AB or BC or CD. Okay, how could we solve this? Let's do an analysis one by one. So we have to make it section. Let's take this part. If we take this part by itself, we will have one force here, one force there, and one force there. So we'll put it like this. One force in the C, we call it FC. Let's see, this force is FC, and this force is FB, and this force is the weight. So force FC, force FB, and the distance between them, let's look at this. What is the distance between point C and point B? You can see 3 feet. So 3 feet between them, FC and FB, and there's the weight. Remember the weight of the crate? This is the weight. And remember, the weight has a distance X, and if this is 3 feet, this should be 3 minus X. So the weight down, X, 3 minus X. Now, how could you solve this? How could you start solving this question? First of all, let's find summation of moment at E. Of course, summation of moment at E, this will cancel out. You'll have this weight that will take it to the negative, minus W times X. And summation of moment at this E, this will be plus FC, remember, times 3. Plus FC times 3. So this will give you equal to 0. You'll end up with, if you just rearrange the equation, FC would equal to WX over 3. So this is the first equation. Nice. Let's do summation of moment at F. You can see that there's two forces. One force going negative, minus FB3. And this force will go positive, W times 3 minus X. So if you arrange this equation and find it as a function of FB is equal W 3 minus X over 3. So this is the second equation. So we have FC as a function of the weight and the X, and we have the force B as the function of the weight times 3 minus X over 3. So these two equations we're going to use later on to find W and X. But now, let's take another member. Remember, let's look at this. Let's go, we took this, one force. Now let's take point C. Point C will have one force here, one force there, and one force there. And this force is the same as the force down. So this is FC. So this is going to be, remember, one force down, one force here, one force there. Remember? CD. And you can see that the angles of CD, 3 in the X, 3 in the Y. And CB, remember, this YB was equal to 1.5. So if the whole thing is 3 feet, this is going to be 1.5 and 3 feet in the X. So 3 and 1.5. And of course, if you want to find this point, 3 square 9 plus 1.5 square, it will equal square root of 11.25. Same thing here, square 9 plus 9 square root of 18. Okay, so we have FCD, if we have FCB, and we have FC at the bottom, and FC we found it before, FC WX over 3, so we're going to make it here WX over 3. Now, how could you do this? Well, here we're not going to do summation of moment, but we're going to apply summation of forces at x equal to 0 and summation of forces at the y equal to 0. But before we start doing summation of forces, remember the question, it said that that the forces AB, BC, or CD is subjected to a tension not to exceed 200 pounds. And we could apply this 200 pound to which one has the greatest angle. So of course the greatest angle should be here, because 3 and 3. This is not the greatest angle, it's 3 and 1.5. So the greatest angle, we're going to assume it, the one with the force 200 pounds. So this is with the greatest angle, so FCD is equal to 200 pounds. Now, summation of forces at the x. FCD, which is 200 pounds, in the x, 3 over square root of 18. 200, 3 over square root of 18. And this is going to be in the negative, minus FCB, 3 over square root of 11.25. So we have this, of course, because we assume this is the greatest angle, so that's why this should have the highest tension. So we end up with FCB now. So we find FCB 158.11 pound. So we found FCB. Now, since we found FCB, we could find FC at the end. So now let's find summation of forces in the y equal to 0. So 200, 3 over square root of 18 plus FCB. We just found FCB. 200 also. Oh no, FCB is 158.11 in the positive y, 1.5 over square root of 11.25 minus FC equal to 0. FC here is WX over 3. So minus WX over 3 equal to 0. You'll end up with the following equation. 212.13 WX over 3. So you could just find WX equal to 636.39. Okay, so we found this equation now. Now let's redo the last point. Point B. Remember point B here? Point B is BC. And you can see that BC has the angles 3 and 1.5, and BA at point B. There is BC and there is BA. BA, you can see this is YB, this is 1.5, and this is 2. And of course, there's the force FB, and we found FB before. Remember the FB? The FB is W3 minus X divided by 3. So we do it like this. So we find FBC. We found FBC before. FBC is 158.11. And now we want to find FBA, and we know FB is equal to W3 minus X over 3, so we're going to put a W over 3 times 3 minus X. So let's do summation of forces in the X and summation of forces in the Y equal to 0. Summation of forces at the X equal to 0. So 158.11, 3 over square root of 11.25, and this is in the plus, and this is going to be in the negative, minus FBA, 2 over square root of 6.25 equal to 0. You'll end up with what? FBA is equal 176.78. So once we're done from this, we found FBA, and then you find summation of forces at the y equal to 0. So we have FBA 1.5 over square root of 6.25, and then you have, this is going to be in the negative, minus 158.11, 1.5 over square root of 11.25. Well, of course, FBC, we know it, so this is going to be a known one, minus FB. FB, which is going to be in the negative y, W times 3 minus X over 3. You put this one as this. You'll end up with what? Now, you just make this in one side, and you make this in the other side. You'll end up with W3 minus X over 3 equals 35.36. So you multiply by 3, you'll end up with, well, W 3 minus X times 3, you'll end up with 106.08. And remember the other one, WX is equal 3 times 212.13, you'll end up with 636.39. So you have these two equations. Now let's open this. 3x minus WX, 3W minus WX equal 106.08. And we have WX, so we just make WX equal to 636.39. You'll end up with 3W is equal 742.5, and then W is equal to 247.5 pound. So we found this. We could just put it here and find X. So if you know W, you could find X. X is equal to 2.57. So for this, we found that the maximum weight of the crate is 636.39 pounds. Oh, no. 247.5 pounds. So the weight of this crate would be 247.5 pounds. And this X, the distance between this weight and this location is equal to 2.57 pound. Feet.